Like you
So,
can start off with like Delaney introduced me to as like he's been down in the weeds for the last few weeks, and I'm losing my marbles.
well, let's start it off there because you have been, and just to
Yeah,
give this some perspective, like we're close to a V1, like we're actually very close, and not that much has changed, except that you decided to go down a very deep rabbit hole and solve a very complicated problem, and it seems like you've come out the other side. So we actually may be close to a V1. I want to say it might even be sometime in April. Um, so uh, tell us, like, tell us without telling us, what exactly have you been working on, and what did you come out the other side discovering?
sure. So man, it has been a weird couple of weeks, or maybe the last month has kind of been me going deep into the weeds. But the long story short is I wasn't happy with the signals that we're doing. Right now we use Preact Signals. And the reason why I've been kind of using that since the beginning was it's simple enough that you can basically read the code. It's not the shortest, it's not the fastest, but it was a good solid thing of like, this works. It's makes sense to me. I like the interface from the outside. Cool. I don't have to worry about this. Let's move on to other harder problems. Um, and then there's been a couple things in that space lately. There's a thing called alien signals, which is kind of the new hotness that does a lot of stuff to be faster. And I started looking at that and looking at the code base and going, I don't get it. Like there's so much going on here. Why is it so complicated to do this? And then yeah, I started going down saying there's got to be more research in this space than just what's been happening in JavaScript. I kind of felt like everyone's doing this optimization of getting faster and faster at solving the wrong problem. And that seems to happen a lot in JavaScript. And I don't know what that is, but it's part of that is the just there's this kind of race to the bottom with the same paradigm. So, uh, what I started to do is started going down the road of like, hey, what other research has been done in this space? And one of the books, there was a bunch of research papers, but there was actually a book put out by MIT called Spreadsheet Implementation Technology. It's by their MIT press. It's great. And the interesting thing is that it is not it's more of a certain implementation. But if I actually saved a page, I know for people listening instead of watching, they won't be able to see this. But I tweeted this page out a few weeks ago, and it is just what spreadsheets are in a single page of like math notation. Like that one page is basically what spreadsheets do under the hood, um, from like a philosophical standpoint. And it took me a bit to get through it. And then I made an implementation that kind of followed that style and then just started iterating and iterating and iterating. And now we have something that's faster than any other JS signal library by like 60 times. Not like 60%, like 6,000%.
Okay, so I'm not gonna let you just throw out numbers like 60x on the fastest signals library there is out there just like that. I have seen the implementation though, and the benchmark results, so I'm not going to deny it either. But we're going to pick it apart a bit, I think, so people understand what it is that we're talking about. Because in my experience, Datastar is already so fast. Preact Signals is what we're using. It is so fast that there is no perceived delay per se. Um, but yes, let's back up a bit. So when we're talking about signals, specifically in Datastar, signals are actually a concept that pretty much every front end framework has its own implementation, right? And Preact Signals has been around for a long time. It's a tried and tested one. It's fast enough. It's easy enough to read. So we have been pulling it into Datastar, or you have from the beginning. And what signals allow you to do is they allow you to set up state on the front end. And when the value of a signal changes, any other signal that depends on that, or a computed state, or an effect that depends on that signal is kind of notified and is able to update and react to that almost instantly. And like I said, every framework has their own kind of different variation of this. There is a proposal to make this native in JavaScript. So signals, it looks like they will eventually be a thing. This proposal is very likely to go through. It's just a question of time. It may be a year, maybe 2 years, maybe less, maybe more. That will mean that the front end frameworks will be able to reorganize around this, and not it won't be a case that everybody has to implement their own. But you said you were looking at the landscape, and Alien Signals claims to be, or at least according to some benchmark results that we have, we'll maybe share in the show notes. Alien Signals claims to be the fastest in terms of the signals libraries, and it's closely followed by things like reactively and then Svelte 5, which is compiled. So you would expect that to be pretty much as fast as you can get. And interestingly, Alien Signals came out of the Vue reactivity engine. I think it's kind of an iteration on that. So in theory, very smart people working on these things who have a ton of experience. And you're claiming, Delaney, that you said, let me read a book on spreadsheets and how they implement this. And you found what I'm guessing is a very different implementation, or maybe a different set of formulae for calculating these. So rather than iterate on what's already been done and make iterative improvements, you've kind of taken a completely different tack and have from the sounds of it, been able to produce incredibly amazing results. If we're talking about like 60x, like that's because the if I look at the benchmarks, I mean, Alien Signals is marginally faster than reactivity, which is in second place, which is marginally faster than Svelte, and now we're talking about 60x, which is more than an order of magnitude. So, so it's hard to believe, but I think that's what happened, right? Delaney read a book and tried something. I do want to mention you tried first, I believe, to port Alien to the backend and port it over to Go. Did that play a role in this whole?
Yeah,
whole thing?
100%. Part of the whole thing was I really like doing the signals style, in that it's not great when you're doing really multi-threaded things, but most things in a individual use case aren't multi-threaded. And you want to make something thread safe in the backend, but not merely multi-threaded for these kinds of things. What it's really good at is setting up relationships. So you start thinking in a like the relationships between different variables, and when this thing affects this thing, and that's conditional on this thing, and you want to only update things when it's necessary. So for certain styles of backend stuff, I've been really wanting signals libraries for a long time, and I've built a couple things, but Alien was fast enough that it was like, okay, they're doing something special here, because it is like twice as fast as any other of the signal libraries for most cases. And I was like, okay, they are doing something special. So I ported the whole thing over. And in doing that, I was like, this doesn't make any sense. Why are they doing this? Like, the irony is that I think this is something that comes from doing game development for a bit, is that you only have so much time in a frame to do stuff. So either you need to be smarter about it or do less of it. And usually the being smarter about it, there's very few things you can do. You can like put things in one long linear buffer, like big dumb buffers are fast, but most of the time you do it by not doing work. And what I mean by that is you'll defer something that can be done in another frame, or you'll defer something here, or you'll only do the stuff that's on frame, or you'll only do like even things like quad trees and oct trees and R trees and all these like bounding volume hierarchies when it comes to collisions. All that kind of stuff is to just say, I'm going to do less checks. That's all you're doing. Like, you're just doing less work, right? So one of the things that came very clear, and I went through all the different signal implementations, is that basically what's happening is that whenever you access a variable inside of a signal, like let's say you're doing a computed that says, I need to use signal A and signal B, and both of those are numbers. Every time you access A or B inside of that computed, that C, it goes and basically adds itself as a subscriber to the results, and then does some checks and then gets the value out. It may be dirty. They may have to redo some calculation. But the point is that every single time you access that function, it has to add itself to a set and do a bunch of subscriber checks and stuff. And if you go look at alien signals, the amount of state that they have to do to track that is enormous. They're doing like recursive checks. They're checking if something's dirty, if it's been propagated. Like just look at the propagate enum and you go, oh wow, they're doing a lot of stuff. The big thing that I did, and this is like, again, it's not about being smart or clever. It's just like stop hitting yourself in the head. Is all I did is said, all these dependencies you know about when you created the function. Like you know that if I need A and B, I don't have to check those every single time this function is called. That's ridiculous. Like you're basically doing like at least multiple inclusions into a set and then checks inside of a set just for a single like int lookup. Like that's silly. You can't, that doesn't scale. So all I did is said, hey, we know what the dependencies are when you make the function. So just add those as your part of your function constructor saying, hey, when I create a computed, I rely on A and B, like the dependencies I rely on. And then what you give it is a callback that is a pure function that says what the contents of A and B are going to be used here. So that's a pure function. So it's just the first thing and the second thing. So if you are, let's say that you're adding those two variables together, that's just a pure function, and you know it's going to get called with the pure values, so that there's no lookups or anything crazy going on at runtime. When you're setting it up, you define the dependencies, and at runtime, you're just calling a function. So there's nothing faster. So instead of doing all these crazy lookups and observer patterns and stuff, and trying to see if something's been added already, or if there's a network of subscribers, you call a function. That's it. Like that's the crazy innovative thing about this is I do all that complicated stuff. I don't do it because you don't need to. Like you just look,
Right.
if you step back and go, I know what my dependencies are in a function. So I tell the function ahead of time what they are, and then I'm done. That's it.
So it sounds like in a way we've moved the work from computation time to setup time, and once you do it once, you don't have to do it again, and you're left with something that is much simpler.
Yeah. So for
And
example, let's
then
say that there was a Boolean in there that said, if let's say there was a Boolean signal that was true, or a conditional thing that was true or false, depending on some other thing, there's a computed that says I'm false. Well, you, even in a pure function, you're still going to rely on that being true or false. But the fact that it's mostly true most of the time, now all of a sudden, because it's a pure function, things like turbofan can get involved and actually see that like most of the time you're on the true branch, and it's going to like do a JIT compiled thing there and do some pretty crazy things. In fact, when I was showing Ben this code base and I was showing what the code it actually generates is, and I saw his face kind of melt a little, because the actual functions that are getting called are like return one, return false, return like a dictionary with this thing false. So like there's no computation happening because the computation's being lazy evaluated at the places it needs to be and nowhere else.
yeah, it did kind of melt my brain because you had been talking about pure functions, and I was trying to imagine how you got there, and that was the missing piece. How do you get to a pure function when you have a set, like a dependency tree essentially set up that you need to? Do you span that? When do you do that? But it really is, I believe, Preact Signals. What we were previously pulling in, or have been up until now, is 800 lines of code, and what you have now is approximately 200 or
It's
250 lines of
130.
code. So
It's 130.
nobody's going to believe you here. Like
I know, like
I,
it's a fifth the size, and it's 60 times fast, or it's probably about 100 times faster than Preact. I don't know what to say. Like, I didn't mean to. Like, I was like, hey, I think I can do a little bit better. And it's not that I did better. I just did less. That's it. Like, that's the betterness of it is, hey, we understand this stuff. And why we'll say one other thing is that because Datastar is declarative, because we're defining things in this declarative syntax, kind of like when you talk about SQL. SQL is a declarative thing. Like when you say create index, you don't know how it's creating index. You don't know what steps. You don't know if it's batching or what. You just say create index, right? Since we have the same thing, the beauty and the bad part about this is, even though we're changing the definition of dependencies, we're changing the way signals work, we're changing how functions are created, all this stuff, this could have been a patch release. Like from the outside, you don't even know that this happened. But we completely changed the entire architecture of how everything worked in this, and it would have been a patch, which I think is pretty cool.
Is there a catch though? Like, is there like, are signals now in Datastar much more complicated? You already said no, because from the outside you just use them the way you did. But are we doing a ton more work, or there must be some catch here? Like, why is it so much fewer lines of code, so much faster, and it's like a non-breaking change?
So I will say that it is more, you have to be more explicit. So for example, when we do when we create the function that generates because JavaScript doesn't have expressions, it just has functions. So we have to take your text, turn it into a reactive expression, and then turn that into a function, because an expression is something that always returns something. So we have to do some things around that. Part of that is now when you generate that function, we return to you the function to call and also what your dependencies are and some other like metadata that then you have to hand off when you actually inside of a plugin call this stuff. It did make the plugin.
Just
Oh,
just to clarify, when you're saying you mean you, the plugin, the Datastar plugin,
sorry.
rather
Yes.
than you, the user, the developer who's using Datastar.
Yeah, users, this does not affect users at all, but someone that's writing a plugin has to be more explicit about, hey, I generated this function. Okay, now here's my dependencies. Here's the function I call, and here's how I call it, stuff like that. So some of that stuff is more in front of your face. But the nice part is it's much easier to actually debug, ironically, because I actually know exactly what my dependencies were at that moment. I know exactly how things are generated, what their paths were, all this stuff. So in some ways, there's a little bit more code for you as a plugin developer to write. But again, we already write all the plugins. No one writes plugins, so we do, or I do. Like this is not a change for you, but in irony, it actually is easier to debug, and it's still about the same amount of code for plugin developers. It's just things got moved around, and it's more explicit with its syntax. There's nothing about what I did that couldn't be done by the solids and sveltes and all that stuff, but it is a different interface, and they would have completely breaking changes. Like this would be Svelte 6 easily. You could not just drop this in to their frameworks, but it would be the fastest thing that's ever been done in that. Like we beat Svelte
We're
by over 100x. Their compiled
Svelte
version. We're doing that
5.
basically on a 5. We're able to beat their.
Svelte 5, that recently released, is supposed to be, one of the fastest frameworks out there. And you're saying we're like we're 60 plus X faster than, and we're not yet at V1. We're like
I
about to
think
launch V1.
I mean, the V1, not V1 doesn't really matter because that's more of a like at the syntax upper level. But the thing that's interesting is I don't know exactly what's happening in their actual compilation. I know that the benchmarks test they have for that part of again, we're just talking about reactivity. We're not saying we're 100x faster in every metric in every way, but I'm saying about signal propagation, which is the majority of your cost of this kind of stuff at runtime, right? I don't know what the actual Svelte 6 numbers would be, but it's kind of hard to test because a lot of the things that we show is that we can do like we can break the browser with how fast our updates are. Like once you get past 5,000-10,000 DOM nodes, the browser starts to fall apart, not Datastar. So that's the kind of issue we're running into. Is that in fact there was a screencast with Ryan Carnito where he's seeing some of the Datastar stuff, and he was like, I don't even know what we're testing anymore because we were like beating them on DOM nodes from the back end when it's a front end test. Like, there's a certain point where some of this stuff just doesn't matter.
He kind of shut down the demo and said,
Yeah.
like, we, but that's a good thing because browsers are just going to get better and processors are going to get faster. And so like, if Datastar is not the bottleneck and the browser is the bottleneck, that's a very good place to be. The reason I say it's important before V1, I know you say it could have been a patch release, but if it does change all of the plugins, then I kind of see it as being a breaking change. So where do we go from here? Like, so this is going to be part of the next, probably the V1, we're saying. And is there anything that we're going to do around like releasing this as its own thing? I think we're going to probably release some benchmarks just to show the performance versus the other front-end frameworks or signals libraries. Any plans? Do you think we will release this as its own library, or do you think it's belongs to Datastar, and that's where it is. And it's more of a pattern than a library that people can make use of.
Yeah, it's a good question. I think that right now, when it came to actually benchmarking this stuff, because it has such a different signature than other libraries, I had to fork the canonical JS signals benchmark just to make the Datastar signals work, because they're not set up with this idea at all. Like no one else does this, right? So I have the fork there, and the thing is, the code's so small, I've just copy pasted it into the setup of the bit, where you import other projects and do all the kind of setup to get it to work with their benchmark. I just copy pasted the entire the 100 lines or whatever into the setup code, because it was small enough that okay, here it is, go for it. Because the thing is that we have certain things where we start using it for paths, and we have these namespaced signals and these other things that are part of that file now that no one else cares about, but I think are very important. Like the namespace stuff is really valuable, but again, no one in the signals space is thinking about that stuff. They're not thinking about being able to have nested sets of namespaces that can be interacted with together. So if anything, we're actually have way more features when it comes to signals than any other library that I know of. But I this is where I don't care that much. If JS authors want to tell me I'm wrong, great. If there's something wrong with my actual benchmark, I want to know, because 60x is a lot. But when you say, hey, instead of doing a bunch of setup every single function, even effects, usually with effects, you subscribe to everything, you do the effect, and then you tear yourself down every single time it's called. And guess what? We don't do that. So when people look at these numbers, they're like, how can you be so much faster? It's because it's a function call instead of a bunch of setup and teardown. That's it. So I to some degree, I would like to engage with some of these authors, because it's look, if I did something wrong with my benchmarks, if it's not 60 to 100x faster, please tell me. I'm not trying to dunk. It's more that guys, you're way off basis here with what you're trying to do. And I think that some of this is a lot of cargo culting on what it means to be what reactivity means. Which is weird, because all this reactivity stuff comes from the Lispers and the closure people and the immutability and monoids and all this stuff. So it actually reminds me a lot of CQRS and event sourcing, which you've heard me talk a lot about. But the weird place is that it's super popular in the C#.NET space. And to me, C# and the .NET ecosystem doesn't match event sourcing or CQRS or domain driven design at all. They make everything so complicated. They make everything bloated. They make I don't understand how it got popular there. I feel like this is the same thing with Signals, that it got popular inside the JavaScript ecosystem, and no one just took a different look. So I do think that having a fresh look from an outside source, I looked at it from a Go dev. In fact, when I was building the Go version, I was like, oh, I already know my dependencies. It'd be better here. Just when I was creating the functions and doing the code generation stuff there, I was like, well, yeah, I already know this stuff. Why am I doing it? For some reason, because JavaScript is so dynamic, you don't really see the costs like you do when you're in something like Zig or Go. One of our community members, James Stevers, he and I have been going back and forth with different implementations. And what's the really, truly interesting thing is he has a version in Zig that is faster than mine, by quite a bit. But the problem is that it's a lot bigger and it's a lot more complicated, and we don't know if it'll be actually faster in the browser. So when it comes to Backend, he actually has a faster version than what I did. So mine is not the most clever version of this. There's better ways to do it. And what's interesting about his is that instead of doing these checks on each effect or each thing, he actually has a global set of values, so that when you say, hey, I'm updating the signal, it already knows where it is in the entire graph. He basically builds a singleton graph of the entire world. So his way is way faster than mine. It's just way more complicated. That's the only reason why we haven't tried doing that in the JavaScript side, because it's just a lot of code, and I don't think it's going to be any faster because of the singleton or the single threaded nature of JavaScript. I just don't think it's going to be that much better.
So would you attribute this different approach and the performance gains you've made on that to you figuring it out on the back end, you and Johnny figuring it out on the back end first, and then bringing it back to JavaScript, taking a new tack on the whole approach to Signals?
Yeah, 100%. In fact, he and I both came to we should be putting dependencies first class independently. Like, we weren't talking to each other. He said, "Oh, I'm working on this thing Signals," which is a great name, and I was working on the Go version of Alien, and I was like, "This doesn't make any sense." And we both were almost on the same day. We're like, "Hey, man, dependencies are like a first class citizen here, huh?" And like, that's it. Like, once you have that, everything else becomes just detail stuff of like, hey, do you want this? How lazy do you want this to be? When do you want this eval to happen? Can we speed this up? Like, simple stuff like that. And most of it actually has to do with the differences between in Go. I'm doing actually a code gen thing. So because it has generics in Go, um, I want to have it so that when you put in a number and a pointer and this some other thing, the function that you give it, the callback that you give it, actually has all that filled out perfectly with types and stuff. So I have to do a bunch of code gen to make that happen, whereas he has the magic of Zig to make his version happen. Um, the irony with that was kind of interesting is that his is faster, like by quite a bit in Zig, but it takes him like a minute or more or 2 minutes to compile, whereas Zig's is like less than a second. So we would do a bunch of tests
Go.
in my version to get a rough idea of like where we're going with it, and then he would redo his on the Zig side. So it was an interesting combination of that's where most of our time was spent. It was the irony that we kept rewriting the JavaScript version because it was so easy. It's only like a few hundred lines at the most. Like, it's actually, it's like almost a little bit over 100 lines. Is that it's just easier to start over each time. Like, we wouldn't even, like, when we talked about it, we wouldn't even copy paste code back and forth. We'd just be like, okay, I'm gonna try this idea, and we just do it real quick because it would take 20 minutes, and you'd be like, okay, I have a new implementation that's kind of interesting. Let's try this idea out.
That's really
Like,
cool.
if
So
you,
it's not that you weren't pair programming, but you were almost tag teaming using different backend languages, but a similar approach until you found the right one or the one that fit, and then you brought that into TypeScript, tested it there. I guess that was your testing ground, more like, and then you carried on developing on the back end. So, because what you said about making dependencies like a first party thing, that sounds very much like the spreadsheet implementation approach, right? Where you need the dependencies to be front and center and as quick as possible. That combined with maybe a back end dev approach, maybe that's what got you there. I find it fascinating, like how you reached this, how you got there in the first place. And it sounds like it's not just taking a different approach to everybody else, but it's also, um, I've used this a lot, first principles, but you went and you read the book on how did spreadsheets do this. Then you went to the back end and you said, how do we make this as fast as possible and efficient as possible? And then you took it to the single threaded JavaScript engine and said, okay, how does it work here? Um,
yeah, and I recommend that
Very
for
impressive.
every.
Yeah, go ahead.
No, I was gonna say I recommend this for everyone in that all I kept doing is going, this seems complicated to me. And there's two different levels to that. There's the I don't understand the process enough. So it's complicated because everything seems like magic if you don't like know how it works, right? Everything in the world, like everything about any process, like understanding that a combustion engine is like a constant explosion going on, right? Like, people don't think about their cars as a constant explosion, right? But like, once you get the idea, like, you understand the mechanisms of that, you understand why things wear and tear, because you're like, there's a constant explosion going on inside of the hood of my car, right? Like, the more you understand, the more you're like, oh, things are complicated because they need to be complicated most of the time. But there was understanding the source material enough to know this seems overcomplicated. Something about this just feels wrong. That this should not be this hard to basically do the observer pattern. That's all signals are at the end of the day. Is it's a publish subscribe where you're saying someone's going to publish to me so that when I change, I can let them know. That's it. So that should not be like 900 lines of JavaScript. I just had this feeling of like, that's not right. And let me get into the weeds of like why that's not right. That doesn't seem like the right path. So I'm always of the whenever you see me on the Discord channel, especially, people may think I'm a jerk because I'm like, you're overcomplicating it. You're making it too hard. Just know that I do that to myself too. I say like, this is a bunch of bullshit. You're making it complicated. You need to stop. And I do that to myself. So at least I'm a equal opportunity jerk to everybody, including myself. Of like, it's so easy to get into the weeds and think that I need all these steps. I need all these things. Like, really thinking it through is valuable to everybody.
Yeah, that's definitely a mantra that we share in Datastar about not overcomplicating things, and it's the reason Datastar I think exists, including your background, and you mentioned pub sub now and how that influenced this. So there's all these different bits of experience and bits of tech and knowledge that have gone into this. And like Datastar is like it's tiny and extremely fast, and it does what it's supposed to do very efficiently. Do you think there's any risk of someone turning around and saying, well, this is no longer signals? Like what we're doing is signals. It's slow and it's complicated, but it works. What you've done here is it's too fast to be signals. Like you can't call it signals because it doesn't work with our way of doing things.
It's literally notifying people of dependencies. Like there's nothing more signally than that. Now, if they say that it doesn't count because it has a different interface, like I'm sorry, like you're taking developer like DX of I don't want to change my ideas to like what it actually does, which is notify people of changes when they happen and do conditional evaluation. That's what signals are. If we want to redefine what they are so that people feel more comfortable with what it is in JavaScript, I guess I don't care. Um, that's why like us making it an external library and supporting it as such, just to like flex on people that we are the fastest. Like, yeah, we're the fastest. As far as I can tell, no one's going to come close to us. And if they do, I'm going to steal their like. I want to take that and make it in ours. Like, there's going to be someone that can probably make something faster, but I don't know if they can make it smaller. Like, so then this becomes an interesting thing of like, does it make sense to make a bigger version that is faster? The other thing that's the irony of this, and this is where like I nerd snipe myself all the time. We don't need this. Like we did not need to make this change because in Datastar you use signals so rarely compared to every other library. So if you're doing like a SolidJS project or Svelte or something, your entire front end is just built on signals. All your state lives in these signals, and propagation really is where all your time is spent. In Datastar, almost everything's coming from the back end. So we use like between 10 and 100x or 1000x less signals than the average JavaScript project. So the true irony is they're like, why did you even, in fact, I remember a little back, you're like, what are you doing? Like, we don't need this. And part of me was like, A, I don't like it because this seems complicated. B, it's not that fast. And C, like, I think it can be smaller. Like all these things like together, I was like, this is an itch that's bothering me really badly. So yeah, the weird part is we still don't think most people should be using more than a few signals on a page. But if you want to do a million signals on a page, we support that now.
Well, we did manage to remove what was kind of an external dependency, Preact Signals, even though we'd modified it slightly and somewhat. That we managed to save a kilobyte since there were just you were able to delete so much code, and now we're 60 times faster. So all of those things put together makes it feel worthwhile. Plus, you've I don't know if this has been done in the signals world before, but it feels like you've invented a new paradigm when it comes to setting up signals in JavaScript, let's say. So I'm sure somebody will build on that idea and make it faster, but that's what you welcome, right? You welcome other people
Yeah.
iterating on the ideas that we put out there and improving on top of them. But safe to say that like signals are done, right? Like we're good now. Once we feel comfortable with this and we polish things up, we're gonna make this stable.
Yeah, good news for everybody is that all the tests.
What's next?
Yeah, all the tests pass now. Like it's not just like, hey, Delaney has this weird implementation that may work, kind of. Um, all the tests pass. Everything's working. We found a few edge cases. We have new tests because of it, and like I feel very confident in that. Most people they're not going to even know. In fact, we put out a little feeler of like, hey, Delaney's doing this crazy stuff. Um, everyone tried this branch, and no one's come up with anything that's actually. They haven't run into any issues yet. So I feel very confident where we're at right now because we have pretty good tests now. We're getting better every time. Thanks to Ben. He's been really doing really great job of every time I'm in these weird deep holes of crazy things, he'll find something and he'll be like, oh, this thing doesn't work. And then he'll make a new test out of the blue. So that's been super helpful to be able to just keep focusing and have unit tests to work off of. So I've been really appreciative about that.
I just want to say, writing unit tests. I feel like I committed to that a while back. We talked about it on here, and it's like it takes a lot of discipline. Like so tempting to just go fix the thing, right? Like someone reports something, I go check it. Oh yeah, I know how to fix that. Put it out there. But no. I have to always remind myself, write the test first, prevent any regressions in future. Future you will thank you. Then go fix the thing. And then you've proven the fix and you've prevented it from ever coming up again. Like the bug.
Yeah,
That
no, Ben has
particular.
definitely been the adult lately.
So yeah, while you've been deep in Signals, let me maybe just give a quick update on where we are currently. We have beta 9. I think we released beta 9 around 3 weeks ago. So that's been quite a long period of stability. We've had a couple of bug reports come in. We've made some minor changes. And we may do a beta 10, which would just be get it out there. But I feel like our next big milestone is going to be V1 stable. And I'd like us to put our heads down. You've been putting your head down for the last week or so, but just to clean things up and get that out the door.
So one of the places where I think it was a really interesting deep dive, because the signal library by itself is very, 150 lines or 130 lines, whatever it is right now. That's kind of interesting, but I think the part that really is interesting to Datastar that's unlike anybody else, most people like Svelte has a compiler, Solid has its JSX compiler. All these people have a lot more information about what's happening in the system, but Datastar is doing it live all the time, and it does it in like a tiny little package. So the way we do that is similar to the way Alpine does it, where we use function constructors. And that basically means that you're able to make a sandbox function. It's like eval, but an actual, like a safe eval that says, I'm only exposing these parts. So what's interesting about the change in the signal thing is, before we could rely on signals constantly doing all their own lookups to basically fill in those function constructors. That was really helpful. It was really easy. It's kind of the way Alpine and everybody else does it. But now, when we talk about pure functions, we don't. We just have values. Like everything's a pure function. So what we actually have to do is generate all of these functions and arguments and all this stuff on the fly. So we take your expression and we generate this pure function version of it. The problem is we also have sometimes where you do mutations inside of your plugin, like you'll do a value equals foo kind of thing. So then we have to put that in. So we have to have partial mutation and like non-mutation and all these arguments. And we're doing this on the fly. And that, without getting into like the nitty gritty of it, we're doing that in like 30 lines of code. It's pretty crazy. It is simple. It looks very simple, and yet it is doing a lot for you. And it's all stuff that you would normally do by hand. I keep saying that I absolutely love what Solid does under the hood, but writing solid JS code is hard. It's hard to get it right. And what's interesting is that we're doing code generation for you on the fly to generate these functions. And it's exactly what you would write if you did it by hand. I just think that's really cool. Like, I'm really happy with that part of it. And it was interesting to see Ben work through the, like, no, we're creating the name of the functions. No, we're inputting the values of it. Like, there's a lot of weird mental gymnastics you have to do to kind of get in the right mindset of like, how do we get these signals that are now talking to pure functions into a perfectly generated expression? Like, that was hard. Like, I will, like, that I'm really happy with.
Yeah, and the code. I'll just add that the code to make that happen is really so terse that it's almost mind bending that you're actually able to do that. And then the realization that I had of, oh, we really just do have a function. We're just passing the arguments directly into it. And therefore, like, the browser has almost nothing to do, right? We've set everything up in a way that is just evaluating that thing and swapping it in where it needs to and just giving us the evaluated result. And that seems like there's almost no work involved. So of course, like, once I'd seen that, I realized, oh, this is why it's so fast. And this is why you were talking about pure function so often. And it all kind of clicked for me.
Yeah, it is interesting because once you go into a pure function thing, you're really allowing the browser to do what it's really good at. Like V8 and the underlying JITs of that are really smart. If you're like, I'm calling this function every time and it has these same values and it has this same structure, it can do amazing things to make it fast. So you're giving it every opportunity. And the thing is that we were already paying people are like, well, now you're generating functions and doing all this stuff. We were already generating functions for you. Like there are no $ foos in, like those are not reactive in JavaScript. So we were already paying the cost. So if we're already paying the cost to do that, and yet we're still the fastest, now we just got a lot faster because we're doing even smarter things inside that function.
It could be really good if we are able to publish a benchmark by the time this goes out, or just something that we can link to that people can see the kind of numbers that we're talking about in perspective with the other front end frameworks. So we'll try to do that. But otherwise, if you're using lots of signals, you're in luck because everything's about to get faster for you. And if you're not, then, it's just business as usual. So,
well, it did get smaller. So there's value in that, right? Like it's one less thing to deal with. And I will say that if you're stepping through the code, it is much easier to know what's going on. Oh, the other thing that has changed with this too is before we would have a bunch of signal events that would happen. Like when you would add a signal or change a signal or update a signal or remove a signal, each one of those would fire off. Like if you said, I'm going to update or I'm going to set food's value and set bar's value and set Baz's value, there'd be 3 signals that happen, signal events that would happen. Now we are batching those things. So there's literally one of those that happens. So a lot of times when you'd have to debalance or you'd get these weird glitchy kind of things, all that's now resolved. And it's faster too.
Yeah. Yeah. So definitely an improvement there as well in terms of the usability of it. That's probably one of the few front facing things that has come out of this in terms of improvements for developers.
Yeah. The only other one that's kind of interesting, just again, these are kind of internals, but it's good for people to understand that like we are caring about this stuff, is that before when you would do namespace signals and you'd have a nested namespace of like foo.bar.baz, it would have to basically take your key and then split it up by by the dot and then go look down the chain inside the thing for the actual signal. Now that's just a single like lookup. So all this stuff is very flat now, whereas before it was this kind of nested object. Now it's using a single map to do all this. And then when it comes to things like JSON, all this, it actually generates an object on the fly, depending on the use case and what you're doing. So like all this stuff got way faster and smaller and cleaner. And I think we're even in a better place than we were before. It's weird to think that, when we started the beta, we were still doing dumb stuff like recreating the world every time someone added a new thing. We literally delete all the plugins and add them all again, which ironically is kind of like what most people do with signals, right? Like they tear everything down and then build it up every time the function call happens, which is literally what we were doing before. And the irony is we said, like, this is not tenable. This is not a good idea. So we fixed all that with mutation observer and some other things. But we literally just did the same thing to signals. Like we just did the same kind of work inside of signals that we did inside of the engine not too long ago. So V1 is so much better. Like we already were fast, but it's even hard to benchmark some of this stuff because again, we run into the browser issue. But the way I look at it is I want to do this stuff and think really hard and deeply about it once so I don't have to do it again. Like I can just trust that is not really going to be our issue, not going to be the bottleneck so that we can focus on other things. So I think we're in a good spot now. I really do. I think this is the end of the road for what we can change. In fact, I was even looking at idiomorph because it's about 700, like it's around 500 or 580 lines right now. And I kind of got the itch to look at it. And I'm like, we're good, I think, for now. I really do. I think other people are looking at that right now. And I definitely have ideas to fix some stuff, but I don't know if it's not going to be a quarter the size or a fifth the size like we are with the signals thing. It's not going to be orders of magnitude faster. Well, it might be orders of magnitude faster. That's again around the idio or the immutable trees and Merkle trees and all that stuff. Like there's some ideas there that could make it technically infinitely faster in certain in certain things because basically you're not having to recheck the world. You basically already have a hash of entire sets of trees. So we can do that later. I'm going to try to hold back on that because the good news is that Micah and stuff has talked about, the guy behind Idiomorph now has talked about helping with that one. So that might be a shared project. But the signal thing was so simple that getting other people involved just didn't make sense. So I am curious to see what the JavaScript community says about it. If anyone knows anybody in that space that's an actual developer of, like if they know the Rich Harris or the Ryan Carnitos, those kinds of guys, or Evan Yu, I want to see what they have to say about this. Like, tell me I'm completely off basis. Tell me that I'm like rigging the benchmarks or something like that. Like, tell me that I'm doing something wrong because, I want to know. This is not, again, I think we can all learn from each other, and I've learned infinitely from what they've done. So yeah, there's the combativeness of like, hey, this is better, like prove me wrong. But also it's like, hey, if you can't prove me wrong, great. Like, let's all figure out what's better. And it may even lead to them making better things. One thing I will say is that the TC39 thing around signals, this may change what that interface looks like because their interface matches what everyone else is doing in this space, and they're wrong. Like, that's what I've now found out. Because again, I was wrong too. I used signals for years. I never thought about it until I sat down and read a book.
Well, I'm confident that this will get us some attention for sure. And we're going to take the opportunity and make a bit of a splash with the V1 and put some benchmarks out there, and we'll see what it brings. People may not believe us, but that's why we're going to put the benchmarks out, and they can prove us wrong or not. The one thing I did want to mention, in addition to the Signals event that you mentioned, is that we're probably going to release a data-JSON attribute simply for outputting all of the signals reactively in JSON format. Up until now, we've done it in data text, and that's kind of been sometimes problematic. So this, whatever we end up naming it, should kind of be a long-term solution to that. Mostly for debugging, but it's very useful when you're developing, just to be able to see your signals and how those are changing over time while working.
Well, and before, just so that people were clear, the way that I was doing it before was just a action that you just ran. The problem is it wasn't reactive. So as things changed on the page, it wasn't automatically updating, which caused it so that you could get the signals at that moment, but you couldn't get them all the time, which is really what you're doing when you're debugging. You're trying to see things live. So Ben worked on the data JSON. What's nice is it's really small. It's this tiny like plugin, but man, it's super useful because it's just doing the right thing and setting up the events correctly. So it's great. Like, that's what that's for. So yeah, no, we're in a pretty good place.
I think we'll wrap it up there. I'll say, well, I'm not here to give you compliments the entire time, but I will say well done on this particular pursuit. The results are extremely impressive, and I'm glad that you decided to tackle this before we released V1. If I'm being honest.
Yeah, I knew
it's
you.
been
I,
great.
I saw the side eye there for a while, going like, "What are you doing? Like why? Like, we're good." No, I think these are the kinds of things that are really valuable, but at the same time, you actually watching the GitHub issues and actually dealing with people's help issues and doing tests and all that is the only reason I can dive deep on this stuff. So, like, honestly, I would have not done this before, or I've completely ignored every other part of the thing of like actually running a community and stuff. So no, I cannot do this without actual help from Ben's and the other people in the community, because otherwise I would just not care. I would just go down this road and it would stay in a private repo. So thank you.
Well, that's why you're the mad scientist here.
Yeah, I guess so.
We will continue keeping our heads down until we're ready for the V1, I guess, and we'll see everyone soon. We'll pop back up when we're ready to announce something a bit more formally.
We'll see you guys soon.